Welcome back to the Learning Studio. You're watching our mathematics series, where we uncover the hidden ideas shaping science, technology, and artificial intelligence. If this is your first time here, don't forget to follow us by clicking the link below, and the full playlist is in the description so you can watch every episode in order. Today, we're diving into a field that explains strategy, cooperation, and competition. A field where mathematics meets psychology, economics, and even AI. This is game theory. Picture this. Two prisoners are caught and interrogated separately. Each has a choice: stay silent or betray the other. If both stay silent, they both get light sentences. If one betrays, the betrayer goes free while the other takes the fall. If both betray, they both get heavy sentences. This famous setup, the prisoner's dilemma, captures the essence of game theory: how rational decision-makers behave when their outcomes depend not just on their choices, but also on the choices of others. Core concepts explained simply. Here are the key ideas: players, strategies, and payoffs. Every game has decision-makers, players, their possible actions, strategies, and the outcomes, payoffs. Nash equilibrium, a state where no player can improve their situation by changing their strategy alone. It's the balance point of strategic interactions. Zero-sum games, situations where one player's gain is exactly another's loss, like chess or poker. Multi-agent systems, when many decision-makers interact, think of self-driving cars negotiating traffic, or AI agents learning to cooperate in simulations. Adversarial ML, in artificial intelligence, game theory underlies adversarial settings, where one model tries to fool another, like in GANs, generative adversarial networks. Why it matters in AI and technology. Game theory isn't just about games, it's the mathematics of interaction. In economics, it models markets, auctions, and negotiations. In politics, it predicts alliances, conflicts, and voting strategies. In cybersecurity, it helps defend systems against intelligent attackers. In artificial intelligence, game theory is the backbone of multi-agent systems, adversarial training, and reinforcement learning in competitive environments. It's how we model intelligence in a world where others are also making decisions. So, game theory gives us the tools to understand competition, cooperation, and the strategies behind intelligent behavior. It's the mathematics of decision-making in a shared world. In our next episode, we'll step into control theory, the mathematics that keeps rockets on course, stabilizes robots, and powers autonomous systems. It's where optimization meets dynamics, and it's one of the most important foundations of robotics and modern AI. Don't forget to follow us by clicking the link below and check out the full playlist in the description. Each episode brings us closer to seeing how mathematics is not just numbers, but a guide to intelligence, strategy, and control.